Just gonna start away a little bit.
We're going to start. We have a data exchange moment. Hopefully this works. Thank you very much. Great to be here, and also these amazing talks before Michelle, Kevin, and everyone else that we've heard so far. Really speaking to issues that are near and dear to us, as I'm sure all of you. Leena, Joe, and I are both, as we mentioned at the beginning, run the Arctic Design Group, University of Virginia. And we're actually here going to talk about a project that we're doing in collaboration with Howie Epstein, folks at Cold Climate Housing, Aaron Cook, and also Tom Douglas at CRREL. So the project really is looking at several kind of key aspects of design in the built environment in the Arctic. And you know, when I say design, I want to be very specific about that. We're architects and landscape architects, Leena and myself. We're really about the building, the design of buildings and the design of cities, and understanding how the systems and social kind of cultural systems come to play within the environmental and technical systems together, and how those become holistic in terms of planning for positive futures for the Arctic. So our project is looking at basically developing a high resolution sensor array in the city of Utqiaġvik. And then applying that data to understand what type of interactions are occurring between the buildings and structures and the permafrost and ground, and understanding how we work as a team and in partnership with community groups here to improve the project and our own work. Just to start off with, just as a perspective, we've been coming up here for quite a number of years with studios and students. And one of the things that's really fascinating for us is always looking at the typology of city in Utqiaġvik, kind of a suburbanized north. Right, you look at the kind of Russian counterpart. This is an Norilsk concrete construction, built on permafrost as well, but very different sort of approach towards design and extreme environment. And so, over the years, you know, we've been working with NSB, TNHA, and various other organizations, including now with the Department of Public Works, to understand the ways in which, you know, we can learn about the context in which the city functions, and also what are the challenges that it's facing. And importantly, having students bring their kind of inquisitive and sort of curiosity into the conversation to understand and question practices that are currently underway. So the first thing really to frame a perspective for the project is to understand this is Utqiaġvik in the wintertime, and this is basically the conditions underground. So we have ice-rich permafrost. This is the CRREL tunnel in Fairbanks, which we take our students to, and CRREL's been very generous in bringing us to understand and see these large ice lenses that are down in the ground in this very sort of silt typology of ground. And so it's a fascinating place to understand the sort of binary kind of between the surface and the ground. And then the essential part, which Kevin, I'm so glad you're talking about this in great detail, is the essential nature of water within the Arctic in terms of controlling and determining the stability of permafrost, which is the fundamental issue at stake. Water in its various forms, from liquid to vapor to snow in its different sort of states. So that's the essential part, as Tor Jorgensen had kind of drilled into our heads many years ago in talks in Fairbanks. The thing that we've been doing, though, is looking at geophysical measurements. This is resistivity, transects on Utqiaġvik, and thinking about how the data that is produced through understanding what's happening below grade, and thinking about the relationship between that and cultural practices, data and cultural data that comes from traditional knowledge, which is another equally valid form of data, probably more valid than the data we are producing through analytical measurements, and thinking about the way to translate this into design. Design, and again, I'm going to sort of underscore, it's not about solving technical problems, it's about looking at the cultural and social value of design.
It's both.
Yes.
I would say it's both, yes.
Do you want to go?
No, go ahead.
So this is Utqiaġvik, and we're going to show you, we've got basically 4 key sites: TNHA, which is a 29-plex housing; BUECI, which is BUECI headquarters, which is the main utility; and the hospital, SSMH, Simmonds Memorial Hospital; and also BEO, we've got a control site outside of town. So we're just focusing on TNHA. We've got a number of so we've got micro-met stations, we've got terrestrial with ground moisture temperature probes, as well as geophysical measurements here. No, we don't. As well as geophysical measurements, resistivity, and GPR beneath TNHA. And then just to cut it sort of very quickly, because I know we're going to quickly blaze through time here. is what we're finding though within the scale of a building like TNHA, which is again, it's a multi-family unit, a 29-plex. We're finding variability in ground temperatures on the scale of a building, right? And variability in terms of settlement. So this part of the building actually has been moving. CRREL's been doing some LiDAR scans. So part of the ground is moving, and it's based on disturbance of the permafrost underneath. What's also interesting is to see the different ways in which snow is accumulating around the building through just natural drifting. This actually happens in this kind of courtyard here, one direction from the west. And what we've been doing is actually modeling the location natural drifting is occurring, but also interestingly, the maintenance practices, right? Where snow is actually plowed and pushed in the city. And maintenance is the essential actor here. And as Kevin was mentioning, which we were just thinking, this is a great lead up to what we're looking at as designers, is how do we begin to think about maintenance as an essential design tool, not only in terms of preserving and maintaining ground conditions, but also in terms of how people might move within a landscape that's being maintained so heavily during the winter, during spring breakup.
Yeah, just to say a few things. The red piles are machine piled snow piles, and then the green is the naturally drifted snow. The one on the left top corner is 20-foot high. This was a measurement from last March, and the one on the right, the red pile, that one is about 12-foot high. And the naturally drifted snow we measured at 8. So these are pretty significant size that has potential to change the ground thermal regime, as well as, of course, impacting the physical accessibility of people, as well as views from the indoors of the houses, which is in the middle. But yeah, go to the next one. And then as Matthew was saying, we were looking at different ways in which the public works are using their equipment, locally available resources, to work with this snow and then the meltwater process. And if you think about it, the tools, go to the next one. The series of these different tools that they already have in their stock, from front loaders to their customized kind of road graders. These are, in a way, tools for, I would say, permafrost preservation potentially, by minimizing or being able to minimize permafrost degradation. Next one. So, some of the things that we've been thinking about is how can we begin to expand the maintenance regime by thinking about, back to what Kevin was saying, how to kind of maybe the snow piles that they make can be smaller so that it reduces or it doesn't interfere with insulating capacity of the snow, and therefore making the ground colder. To, if it's going to be a bigger piles of snow, as we're in the kind of the second column, push it all the way towards the lagoons. That's not kind of the meltwater is not draining towards the foundation of the building, for example. And these are some of the things that we've been thinking about along with our students. And then in the urban scale, what you see in the kind of orange lines, short lines, are the locations of all the existing culverts. So if you're to kind of expand all of these at the urban scale and kind of placing the snows or the dump sites, in with where the drainage sites are, but also, go to the next one, how at the bottom, kind of three-dimensional kind of view of the city, how the kind of site-specific conditions, as well as the uses from housing to schoolyard to playground and so on, can begin to bring a kind of better coordinated strategies for maintaining snow, as well as its impact on the ground, as well as the social implications.
Yeah, because in a way, thinking about scraping the ground clear, allowing air temperature cold in the wintertime to overfreeze the ground, and then compacting snow, changing its thermal properties, is an essential tool that can be used in terms of mediating ground conditions and permafrost stability. Going on to the hospital site, we're going to jump through here, looking at some of the sensor locations we have. Again, micromet stations, ground temperature probes, as well as geophysical measurements that are underway. This is a really kind of dense diagram, but just to kind of quickly summarize, these are 3 locations in the building. This shows depth, and it shows over time the ground moisture content. What's really important here is this tiny little drawing at the top here, which shows our BO control site. The size of the circles is telling you the moisture content of the ground. And what you basically see is there are bigger circles around the hospital site than there are at our control site. In other words, there's a lot more water. What's weird about the BO, so the hospital site, this is built in a bowl, and so actually water accumulates in this bowl, it's plowed and so it's a big problem for them. We've been working with ASMA to actually look at ways to remediate the situation. but also importantly is to think about ways that it can activate the space as well, not just solving a problem of drainage. The other thing that's actually kind of interesting here, just as a footnote, is just looking at the impact of a road, which you've all seen images like this, where the introduction of a road and then drifting and snow accumulation creates increased degradation of permafrost just through increased snow and melting and what that does in terms of the energy balance of the surface. Underneath a hospital, you're seeing also a lot of accumulated water. So what we did with our students is we looked at an existing site plan for the hospital on the left here. It's super dense. I don't expect you to come here. They pointed out a number of issues that were of concern, and we began to then do some analysis and looking at studying the site, understanding where snow is accumulating and thinking there's a drainage problem here, but there's also a problem in this terms of the hospital being a central role in the town, but there's no way to actually engage in other than going inside. And so what we did is start to think about, okay, let's look at, first of all, the drainage problem. This is just modeling surface drainage. And then look at how we can think about activating the space around the hospital for people, but at the same time as also solving this drainage problem. And so what we did is actually start to look at programmatically thinking about a path and a trail and gardens that actually become health and well-being.
Which is what they wanted. Yeah.
And so we began to think of that as a way to sort of link what's going on in the interior to the exterior spaces. And so that then changed the drainage pattern on the ground because those paths are actually controlling where water is flowing. You can see sort of very more focused drainage if you come in with the early one. And then thinking about the design of the path itself as a kind of key activation element. So that's zooming through it super fast, but they should maybe get an idea of what we're trying to do. This is just from the comprehensive plan of Utqiaġvik. This is the future expansion of Utqiaġvik. So
we know where the hospital is.
Yeah, the hospital's here. And what we did is actually there's a hospital, so the shift of the kind of frame of the image, started looking at the grade topography of the site, looking at drainage, looking at where the watersheds are, and also looking at how water would flow in that area, and thinking instead of just continuing with a linear rectilinear sort of planning kind of strategy, why not think about maybe a planning strategy that may conform more to the sort of natural drainage patterns of the tundra itself. Yeah. The last thing we will just talk about briefly is just our approach to architecture and design in general in buildings. This is actually a design, this is a drawing that explains the systems at work in a building, thinking about human interactions as well as energy and other sort of functional technical aspects. And so, when we sort of start to draw plans and sections of buildings, we think about not only the energy balance, but also the way in which people are actually potentially, which is catalyzing the usage of space. This is a house that was designed that shows thermal kind of the sort of vapor pressure conditions as well as thermal conditions within the house, but also the spaces for living and a kind of engagement. I'm thinking, how do we create homes that are actually spaces that people want to be in, that prioritize the use and cultural needs that they have, as well as solving the technical and engineering challenges that exist. Yeah. So just to wrap up, this is a kind of just summary of what maybe defines our approach. What is essential, we believe, is coupling of Arctic landscape and built environment. Those two things need to be understood to understand the challenges of global climate change. We really believe that there's an imperative at the moment to question design conventions that are usually imported from temperate latitudes. But also importantly, what happens in the Arctic is that oftentimes that because of logistical challenges, the designs that are produced for housing and other structures prioritizes overcoming logistical and economic challenges as opposed to design of the spaces for the people occupying those spaces, which is very different. Collaboration is an essential part of bringing action-oriented changes to people and communities in the North. And cultural and social benefit is of equal or greater importance to, this is actually really important, cultural and social benefit is of equal or greater importance to technological innovation for the built environment. Hands down, make a building less efficient, make it better and healthier for the people living there. I think that's a great idea. I'll end there. Thank you.